All right. So we're going to kind of veer off the calculus train for a moment and talk about some summation notation and some summation shortcuts. And I promise you, we'll get back to calculus. But right now, like this will all come together, but we got to remember some of the basics. Okay, what is that big E thing? Ah, sigma. That is a sigma. What does a sigma mean? You add it all up. That is what a sigma means. Okay. So it means summation, sum them all up. Okay. This guy right here tells us where to begin. It's our lower limit. This right here is where we stop. This is our upper limit. And then this is what we call the index. We're plugging numbers in to the index, starting at M, ending at N, and then we add those up. You will see nothing with antiderivatives today. We're taking a break for a moment. Really all week. Well, yeah. I know. Are you drinking like Mountain Dew? Oh. Oh, okay. You know, I'm really enjoying this yellow day because it's very like springy and colorful, you know. Yellow makes you anxious? I'm so sorry. Well, I get it. Okay, so write this down. The sum from k equals 1 to 5 of k squared. Notice how this is a k and there's a k in here. That's a good sign. Those should match. No, it's a problem if they don't match. So if I ask you to write the in summation notation, they should match. All right. So when we plug in 1, we have 1 squared. And then we plug in 2. And then we plug in 3. And then we plug in 4. And then we plug in 5 and stop because that is our upper limit. 5. What is 1 plus 4 plus 9 plus 16 plus 25? Ooh, look at these. Well, this is what I would do. I would take 9 plus 1, right? Plus 25. Okay. What about this one? Oh man, I'm so confused. Yeah, you can. What do you get when you plug in 3? What do you get when you plug in 4? What do you get when you plug in 5, 6, 7, 8? Maybe not the most appropriate quote, but we're there. Okay. What? We start at 3, we end at 8. Yes. Repeated addition is multiplication. So yes. 42. Isn't this a nice little break? Yeah. Okay. Why is this so terrible? This one right here.
It's not like it's third grade math. Yeah.
I don't know. My third grader might be able to do this.
No, like your grader is a child of the math. Is that a flex? Isaac, that's literally, what are you talking about? Your third grader can't understand what a Isaac, you say that. You say that your child.
Is it easier to imagine a number with just like a?
So today, this I is a variable. It's okay. When we plug in 2, what do we get? 5 plus, then we're going to plug in 3. Isaac says 15. Do we have a plus? Then we're going to plug in 4. Okay, in general, this is what you're going to see. We're going to have the sum from k equals 1 to n of b sub k. And so you're going to take the first term plus the second term plus the third term plus all the way until you get to the nth term. Right? Okay. Glad you think so. Okay, now we're gonna write down some properties, and these are gonna seem sort of meh, but when we get to next week, and we're talking about how this relates to integration, it will be important. Okay, so if we have a constant on the inside of our summation, we could take it to the outside of our summation and take care of it later. If we are adding 2 things inside of our summation, we can break it apart into the sum of 2 summations. And same thing with subtraction. So if you want to combine the second and third, you can.
is sigma variable plus a constant also equals sigma variable plus sigma constant? That's
Yeah.
not- Okay.
Like if there's the summation inside,
Yeah, like if it's x plus 2, it does that equal sigma x plus sigma 2?
yes.
Alright.
We're on the same page. Okay.
Yeah, but
You what?
I'm just copying this stuff.
Okay. So how can these be helpful? You're not gonna see like the immediate benefit right this second. We're just gonna kind of take a little step, talk about them, and then we're gonna talk about something else, and then these will be a lot more helpful in a little bit. Okay, so like if we had the sum from k equals 1 to 3 of 2k. Well, what? Okay. Yeah. But what I want to show you is that we could totally take 2 out in front and multiply it by the sum of 1 plus 2 plus 3 to get the 12. Now, like I said, you're not going to see like the immediate benefit. I just want to show you that that is a possibility. Okay. Did it really make our lives that much easier? 3 pretty easy numbers to add together, but okay. Technically, we could take the sum from k equals 1 to 4 of k minus k squared, and we could break it up as the sum from k equals 1 to 4 of k minus the sum from k equals 1 to 4 of k squared. This is probably the first time in last week and this week that I've had a class with 100% attendance. Good job.
Do you think we'll do what like Lincoln and Grand Island are doing, like doing 4-day weeks?
I doubt it. I feel like that's not what our superintendent wants to see, but as a teacher, I think it really would help.
Would we have to like make up days?
I know nothing. I know nothing. All right. So, and I'm sorry, guys. I'm really sorry. We have a lot of writing things down today. And I know it's not like super fun and exciting, but I'll try to tell you some jokes as we go along. Okay. My first grader really loves jokes. So him and I went out to eat together as just like some one-on-one time, and we looked up a bunch of jokes. So I'm gonna give you some shortcuts that we're gonna use. Okay. And I actually find these to be very, very helpful, even in my real life, okay? So if we have the sum from k equals 1 to n of k, so if we're just adding integers, then we can take n times n plus 1 all over 2. Boom, we're done. And I've actually used this shortcut before. Math club, we use this shortcut all the time. Why did the computer go to the dentist? It had a Bluetooth. Thank you. Why is a baseball stadium always cool? It's full of fans. All right, here's our next one. If we're summing up squared numbers, here's our shortcut. Why did they quit giving tests at the zoo? Yes. What do you call a pig that knows karate? It's like you've heard that one before. What animal needs to wear a wig? Yes. What room can no one enter? A mushroom. What has 4 wheels and flies? Yeah. That was the right answer. Okay, my son will really like that one. What do you call fake noodles? Impasta. All right, are we ready for the next shortcut? If we're going to add up a bunch of cube numbers, does this look familiar right here? Oh, that's the first one, and we just have it squared. Cool. What do you call an old snowman? Water. Why couldn't the pirate learn the alphabet? He was lost at sea.
Where are you getting these?
So if you listened to me about 3 minutes ago, my son really loves jokes, and him and I went to dinner together to spend some time together. And while I was waiting for him to finish eating, because he's the slowest eater ever, I was telling him jokes. So it's just this website full of jokes for kids. Red Robin. That's what he really wanted to go to. Okay, last one. What are the strongest days of the week? Saturday and Sunday. Every other day is a weekday. Oh, okay. I do like this one, and then I'm done. Why do bicycles fall over? They're too tired. Okay. So do we have these written down? If anybody is gone in 5th hour, they're going to get just a great lesson today. I know. I record every day. Yeah.
I was in your recorded last.
Yes. Lucky you. All right. So here we go. Instead of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 all the way to 23, you're writing this down, and then we're going to use our shortcut. So our shortcut for the sum of n is n times n plus 1 over 2. So we're going to take 23 times 24 divided by 2. 276, Quinn did in his head. Yep. Fact. Wasn't that way better than adding all those numbers up? All right, next example. Write it down. Wah, wah, wah. Hmm?
It's a fancy, it's a sideways map.
All right, so since this one, we are summing up k squared from 1 to 7, we are going to take n times n plus 1 times 2n plus 1, which would be 15 all over 6. So we have 7 times 4 times 5. Well, 6 is 2 times 3, right? So 8 divided by 2 is 4. 15 divided by 3 is 5. So
Oh, yeah.
am I like blowing your mind right now? Seriously? I just canceled out factors of numbers. Okay, let's go through this. So this is 2 times 3, and this is 4 times 2. So the 2's cancel. This is 5 times 3, and the 3's cancel. So we have 7 times 4 times 5.
We're not used to having several constants multiplied in the numerator. So we never really got over the.
Okay. Okay, here we go. Last one of this type, and then we have one more thing to talk about. Okay, now luckily, the k and k cubed have similar shortcuts to where we don't have to like memorize too much. Okay, so we're gonna take n times n plus 1 all over 2 squared. Okay, what's 6 divided by 2? What's 3 times 7? We have 21 squared. I would rather divide with smaller numbers. Like 6 divided by 2 as opposed to 42 divided by 2. You're right. Okay, now let's talk about this one. No. Just write it down, and then we're going to brainstorm what we can do given the information we just went through. I don't see a constant. We can distribute. And then we have a property that says, oh, this is what it says, according to Isaac. Okay. I would have done the same thing with my hands, Isaac. That's not helpful. Now we can use 2 shortcuts. Oh, man.
Is there like a shorthand for sigma?
Uh,
My hand's cramping.
Okay. So k squared from 1 to 30, we're going to have 30 times 31 times 61 all over 6. Yes, okay. And then the sum from 1 to 30 of k is going to be 30 times 31 over 2. So where it's like 17? Just kidding. What's the answer? Can you say that number appropriately? Okay, good. Just making sure you know. 9920 is the answer according to Isaac. Okay, now we have one more thing that we need to write down, but I need to hear 3 positive comments before we move on. This is fun. Matt loves life.
Omelets are delicious.
Omelets are delicious. What do you like in your omelet?
Again. I like let's just scramble it. Talk about food around here. It wins every conversation about food. Mushrooms.
Okay, so we know that 1 squared plus 2 squared plus 3 squared plus 4 squared all the way to n squared is the same thing as n times n plus 1 times 2 n plus 1 all over 6. This is what we call closed form, and this is what we call open form. Okay. So you are going to get some problems, and we'll do an example here in about 1 minute, where I'm going to ask you to take a summation and write it in closed form. That would be what is on the left there. I'm so thankful you all are here today. Math is so much better when everyone gets to be here. It's even better when what?
That's not a positive comment.
I'm just so good at it, I don't have to do it.
Going to be our theme for the week. We are going to avoid negative comments. Okay? Okay.
You should make that a sticker.
I have that. All right. Do you have this written down? We need to write this in closed form. What? How do I write this in closed form? Henry, what are we going to have to do? Yeah, I like that he said distribute instead of FOIL. We're so past the days of needing to use the word FOIL. Or we need to expand the square of the binomial. You could say that too. You could FOIL, yeah. Okay, so do you see how up there is n instead of like a number?
Yeah.
Okay, so we have the sum from k equals 1 to n of 9 plus 6 times the sum from k equals 1 to n of k plus the sum from k equals 1 to n of k squared. The sum from k equals 1 to n of 9. What does that mean? 9n plus 6 times the sum from 1 to n of k is n times n plus 1 over 2. And then our sum from 1 to n of k squared is n times n plus 1 times 2n plus 1 all over 6. So something that you did not get to learn in pre-calculus last year was a method of proof called proof by induction. And in our sequences and series chapter, I could have taught you how to actually prove why these formulas are what they are. But we decided to skip that because we had to add other content in for what you missed in Algebra 2. I don't think you're disappointed. Up here. They only seem to be used by my wrestlers. I'm not blaming you. I'm just saying Hank Kriegler has already used 2 of them. And now you. That's why they're here. All right, so you have homework tonight that you're gonna do. Please do not forget about how to do antiderivatives. Okay, you're still gonna have a rule quiz sometime. Luckily though, tomorrow we get to find area of rectangles, and Friday we get to find area of trapezoids. So we're looking at a very geometric week. I don't know if that's good or bad for you. Oh, yes, and that's a good point. We're a day off. So today's the 19th. You need to look at the 18th for your homework because of our snow day. Kind of okay, he says.